start by getting the equation set equal to 0. So I moved the negative 7 over to the left-hand side. I made that plus 7. And then I'm looking at the 4 choices, and I do see the choice 3 and 4 kind of look quadratic formula-ish. So I'm just going to go ahead and do that. So I have x equals negative b, which is negative 2, plus or minus the square root of b squared, which is 2 squared, which is 4, minus 4 times 3 times 7, and that whole thing is over 2 times a, which is 2 times 3, which is 6. All right, so let's keep going. So we have x equals negative 2 plus or minus. Then underneath that square root, you're going to work all that out, and that's going to be negative 80. So right away we see that that's going to be an imaginary number, and let's see if we can simplify that. So that's going to be the square root of negative 16 and 5. Remember, the square root of negative 16 is 4i. Anytime you have a negative underneath the square root, that's an I. So that's going to be negative 2 plus or minus 4i radical 5 over 6. Okay, so then at this point, what I'm going to do is I'm going to separate this. So I'm going to write x equals negative 2 over 6 plus or minus 4i radical 5 over 6. Okay? And then I can reduce both of those fractions. So the first fraction is going to be negative 1/3 plus or minus, and then the second fraction is 2i radical 5 over 3, because we're dividing both of those fractions by 2's. And then you can see that that answer is choice 3. So they're asking for the probability that a person texts over 50 messages per month. Okay, so what I'm going to do is I'm going to take that over 50 messages per month, and I'm going to call that A. And then it says given, which is a big thing, that the person's between the ages of 23 and 60, so I'm going to call that B. So rule is probability of A given B equals, that's an equal sign, sorry, probability of A and B all over the probability of B. All right, so what we're looking for is we're looking for the probability that we text over 50 messages and between the ages of 23 and 60. All right, so here's the column for over 50, and between the ages of 23 and 60 would be this row. So that overlap right there is 157. So we know that the numerator is going to be 157. All right, next we're looking at the denominator, which says the probability of B. B being between the ages of 23 and 60. So all these people right here are between the ages of 23 and 60. So what I'm going to do is I'm going to add those up. And when I add those up, let me just circle these so you can see, I am going to get 229. So then my denominator would be 229, and that answer is choice 1. Let me see if I can scoot this over. There we go. So choice 1 it is. All right, so my answer choices are cut off here, but you should see them on your page. Basically what they want you to do is take the C of M equation, which we have right here, and they want you to set it equal to 0, which means they want you to solve it. So we're going to have m cubed minus 2m squared plus 4m minus 8 equals 0. All right, well I have 4 terms, so I'm going to group. I can take an m squared out of the first 2 terms, and I get m minus 2. I can take a 4 out of the second set of terms there, and I get m minus 2. All right, so then I've got m squared plus 4, and then I've got m minus 2 equals 0. So remember, if it says equals 0, we want to do our t-chart and we actually want to solve. So I'm going to take m squared plus 4, set it equal to 0, and I'm going to take m minus 2 and set that equal to 0. Well, that one's pretty easy, right? We just add 2, and we get m equals 2. So there is one of our solutions. Okay, now over here, we're going to subtract 4, and we'll get m squared equals negative 4. Now, remember that if we want to get rid of that squared, what we would want to do is we want to take the square root, because that will cancel out that square. But remember, when you take the square root, you need a plus or minus in front of that. Okay? So just be careful, don't forget that plus or minus. So we have m equals plus or minus, and the square root of negative 4 would be 2i. So we have two non-real solutions, the plus or minus 2i, and one real solution, m equals 2. So your answer, if you look at your choices, is going to be choice 4. So they gave you the equation for p of x. So all I did was I put that in my y1 in my calculator, and I got a picture. So the picture kind of looked like this. Okay, and then if you look at the 3, and let's call this p of x. Then if you look at the multiple choice options, you see that they're talking about roots. And this one here is m of x. So remember, roots are where a graph hits the x-axis. So if you see p of x has 1, 2, 3 real roots. However, m of x has 1, 2 real roots. So that's choice 1. All right, so for this question, the first thing that I would do is I would see that the midline is right here at y equals 9. So I'm going to start by finding the amplitude. And the amplitude is the maximum, which I see is, what, 10, 12, 14, minus the minimum, which is 4. And then I'm going to divide that by 2. Maximum minus minimum divided by 2. Okay, so when I do that, I get 5. So then I know that my answer can't be choice 2. Oops, let's try that again. It can't be choice 2, and it can't be choice 3 because their amplitudes are 9. All right, so now if I look at the rest of those, well, I can look at choice 1 and I can look at choice 4, and I see that choice 1 is a cosine curve and choice 4 is a sine curve, and, well, I've got a sine curve. So then I know my answer is choice 4. Now, let's pretend it wasn't a multiple choice. I'm just going to go a step further and just show you. Remember, the period of the graph is how long it takes to complete one full curve, and this is one full curve. So my period is 12. So remember, to find the frequency, we do 2 pi over the period, which is 12. And that's how they're getting pi over 6. Okay? And then the last thing is that plus 9 at the end, and that plus 9 is that vertical shift. And here is your vertical shift. Your vertical shift is the same as the equation of your midline. So when I started this question, I started by looking at what the value of x is, and I figured, well, we have to do some distribution here. And obviously, when we square a term, in this case a trinomial, we would write it twice. So I'm just going to start by taking the a in the first set of parentheses, and I'm going to distribute it through to everything in the second set of parentheses, just like that. So I'm going to get a squared plus ab plus ac. Then let me just switch colors here. Then what I'm going to do is I'm going to take everything, I'm going to take the b from the first set of parentheses, and I'm going to multiply it by everything in the second set of parentheses. I'm going to try to combine like terms as I go, or line them up anyway. So I get AB. Then I'm going to multiply and I'm going to get b squared, which I don't have one of those, so I'm going to put that out here. And then I'm going to get bc, and I don't have one of those, so I'm going to put that out here. All right, let's change the color one more time. Let's go with black. All right, so then lastly, I'll take the c and I'm going to multiply it by everything in the second set of parentheses. So that gives me AC. So I'm going to line that up with that AC up at the top there. Then it gives me BC. Well, I've got one of those. And then it gives me c squared. Now, I kind of can't fit c squared, so I'm going to put it all the way here in the front, if that's all right. All right, so what I notice is, when I'm looking at this, I'm just going to kind of explain. I see a c squared, I see an a squared, and I see a b squared. So, just because I'm a little crazy, I'm going to line those up alphabetically. So a squared plus b squared plus c squared. Okay? Then, if I look here, I have ab plus ab. So I can add those, and that is going to give me plus 2ab. Then I'm going to have, next to it, plus 2ac, and lastly, plus 2bc. Now, I want you to notice what we do have here. Notice, and let me just change colors, that what I have here in the beginning, that is equivalent to y. And then if you look at this second part right here, that's almost equivalent to z if that z was multiplied by 2. So then you can see that that answer would be choice 4. So this question is asking for a recursive formula. So recursive, remember, we're going to have 2 equations, so therefore we know it can't be choice 2 or choice 4. Now, recursive starts with g sub 1, and that's always your first term, so that doesn't eliminate choice 1 or choice 3. Let's look at the difference between choice 1 and choice 3. Choice 1, notice that this first term here, which is your r, is 1/2. Notice over here in choice 3, this first term here, which is your r, is 2. So if we go over and we look at the original sequence here, we can see that to go from the first term to the second term, we are decreasing. So we would be multiplying in this case by 1/2. So 18 times 1/2 is 9, 9 times 1/2 is 4.5, and so on. In which case then our answer would be choice 1. All right, so they're asking you to write this fraction in simplest form. So what I notice is I have 4 terms in the numerator, so I'm going to factor those. So I see that the first grouping has an x squared. I can take that out, and I get x plus 2. The second grouping has a negative 9. I can factor that out, and I also get x plus 2. Oops, let's make that look like an x. All right, in the denominator, I notice that I have a common factor of x, so let me factor that out. And that would give me x squared minus x minus 6. All right, so let's keep going here. So that's going to give me, in the numerator, x squared minus 9 and x plus 2. And then I notice in the denominator, I can continue factoring that trinomial. So that's going to be x minus 3 and x plus 2. Now I also notice in the numerator that I've got dots, so I'm going to keep going with that. So I've got x minus 3, x plus 3, and then I have x plus 2 that I'm going to just bring along for the ride there. And then I have x times x minus 3 and times x plus 2. All right, so remember when we're simplifying fractions, any common terms that you have in both the numerator and the denominator, you can cancel out. So we can cancel out the x plus 2's. We can cancel out the x minus 3's. Okay, and then you can see this is what we have left. Now, I'm going to make that look a little bit prettier. So that would be x plus 3 in the numerator, x in the denominator, and so then our answer would be choice 3. Now, this is a multiple choice, so what you could do is you could store in a number as x. And what I would probably suggest that you do is store in a number as x, and then you would type in this entire fraction, and you'll get a numerical value. And I would write that numerical value down. And then just plug in these choices using that same value of x that you stored in and see which one gives you the same value you got when you plugged in this into your calculator. Okay, so that's another option. And especially when it's a multiple choice, it's a good cheater option. For number 9, they're asking for total number of miles. So we could either use our summation symbols here, or we could use the sum formula. So let me just kind of quickly explain to you why the sum formula, choice 3 and 4, we're actually going to say are not options. Because remember, the sum formula says a sub 1, which in this case is 8. So a sub 1 minus a sub 1 times your r, which is 1.10 because we have a 10% increase, okay, to the n power. Now, n would be 6 weeks, so we would put a 6 in here. All over, now here we go, 1 minus your r, and your r is 1.10. And when you when you subtract this, you're going to get negative 0.1, which I don't have in the denominator of either of these fractions. So that's how I know the choice 3 and choice 4 will not be an answer choice. Okay, now, if you recall, if we're going to use the summation formula, obviously it's over a 6-week period of time. So if you look at both answer choices, we're starting at time 1 and going up to 6. So that doesn't help us eliminate. Really, if you look at everything, the exponent is what we have to kind of figure out. You know, is it going to be an exponent of n minus 1, or is it going to be an exponent of n? So if you recall, when we're using the summation symbol, we always want to use the explicit formula. And since this is a geometric series, the explicit formula is a sub 1 times r to the n minus 1. And there it is right there. Okay, so our a sub 1 is 8. Our r is 1.1 to the n minus 1. And again, we're going from time 1 to time 6. Okay, so therefore you can see that the answer would be choice 1. Okay, if you read the question, it says that the violet light, I'm looking at the second sentence, has a wavelength of 400 nanometers. That means how long it takes to complete one full curve. Okay, so that stands for the period of the graph. So the period of the graph is 400. Now, they also say that it's a sine function. So let's do this. So remember, a sine curve starts at 0, 0. It goes up, it comes back down, and then it ends right there. And that would be at 400. Which means then the middle, which would be right here, would be at 200, right? Half of that 400. Which then means, and let me put this in a different color so you can kind of see it a little bit better, the maximum here, sorry, I was trying to dot that didn't work out too well, would be at 100, right? And then the minimum here, there we go, that's a little bit better, is at 300. So now if we read it, the last sentence says, over which interval is the height of the wave decreasing? So when is the height decreasing, meaning going down? Well, it reaches its maximum at 100 nanometers, and then from there it keeps going down, 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 till it gets to 300. So that would be choice 2. So this question is asking for a recursive formula. So like on one of the other questions that we did, recursive will have 2 equations. So it can't be choice 1 and it can't be choice 3. So we know it's got to be choice 2 or choice 4. And let's look at the difference. Here we go. So one of them, that rate of depreciation is raised to a power, and then over here it's being multiplied in choice 4 by a sub n minus 1. So let's just kind of go back to what the recursive formula is. And that's a sub 1 equals, and then it's a sub n equals a sub n minus 1 times your rate. So right there, then we can see that the answer is choice 4. Okay, and since the average rate of depreciation is 8%, that means we're doing 1 minus 0.08, which would give us that 0.92 that you see in choice 2 and choice 4. Okay? All right, let's look at number 12. Number 12 wants you to find an equivalent answer to the fraction that they gave you. So my first thought is you can do one of 2 things. We can cheat. So how about we talk about that first? I know you like that, right? So again, store number as x. Plug this into your calculator. You'll get a numerical value. Write that numerical value down. Then plug this into your calculator. Do you get the same answer? Your answer should be no, you don't. So then plug in choice 2 into the calculator. Don't change the number that you stored. Okay, and you will see that that is the correct answer. So the answer is choice 2. Now, let's do it the good old-fashioned algebraic way, because honestly, guys, this easily could be a a non-multiple choice question. So I would go with long division. And we get x cubed plus 2x squared plus x plus 6. All right, so here we go. So x times x squared would give me x cubed, right? And then don't forget that you need to multiply your 2 by your x squared as well. Okay? So that's going to give us 2x squared. All right, then from there, we have to remember that we have to, well, this is a positive x cubed, so we circle and change, which will cross this out, and it'll cross this out. So in which case, let's bring down the next 2 terms. All right, so when we bring those down, we get x plus 6, and then I would just be multiplying by 1, right? So I get this 1 here. I'm going to multiply it by the x, and I'm going to multiply it by the 2 as well. So that would give me x plus 2. All right, now just remember that we have to circle and change, circle and change. So the x's will cross out. And then when we do 6 minus a 2, we will get 4. So then that would be plus 4 over x plus 2. And we look at this, and we look at that, and we see that they're the same thing. There's your answer. All right, so just remember that inverse means to switch the x with the y. So do also remember that f of x is just a fancy way of saying y, so that's a y. So if I want to find the inverse, I'm going to make that y an x, and I'm going to make the x cubed into a y cubed, and then minus 2. So there's my inverse. Now, the next step, though, is I have to get the y by itself, right? So I'm going to add 2 to both sides, and I'm going to get x plus 2 equals y cubed. All right, now, from here, I want to try to get the y by itself, right? But right now, it's attached to a cube. Similar to when we have if it's attached to a squared, we would square root, right? So what we're going to actually do is, when it's attached to a cube, we're going to cube root, because those will cancel each other out. Obviously, if I cube root one side, I cube root the other side. And then we end up with the cube root of x plus 2 equals y. Now, if you look at the choices, they all say f inverse, so we're going to just replace that because that's the function notation. Okay, and then we have the cube root of x plus 2. So there is our inverse equation. And then we just go over, we look at what we got here, and that's choice 3. Okay, so we're looking at a 4th degree polynomial, and I think that I'm missing answer choices here. I have a feeling that they're on the other page. So, you know what? I'm going to draw them in. No big deal. So this is going to be answer choice 2. And answer choice 2 looked like that, right? Kind of like that. And it had arrows. And then answer choice 4 looked like this. And it had arrows. Okay. Now, so let's look here. First of all, they're saying that the zeros are at -5 and 3. And you can see, if we look at choice 3, this is not -5, and that is not +3. Also, I didn't draw it, but you have it on your answer, on your sheet rather, that this is a -3 and this is a +5, which is not what I have up here. Okay, so let me just write those in real quick just so we're not confused. But again, this is a -3 on your paper, and this is a +5. So since that's the case, we know that these two cannot be options for us. So it's got to be choice 1 or choice 2. Now, look at choice 1, though, and compare it to choice 2. Okay, choice 1, not only does it have a 0 at -5 and 3, it also has another 0 here, some negative number that's closer to 0, but I don't know, that could be -1 or it could be -2 or something like that. And over here, it has another 0 that's a positive number, something that's bigger than 0, something between 0 and 3. These are not positive and negative real numbers. They're imaginary numbers. So we shouldn't be seeing them intersecting the x-axis. So then in this case, choice 1 can't be a possibility. Whereas if we look at choice 2, we can see that we have imaginary roots. They're not intersecting the x-axis. Okay? So then our answer, oops, let me get my pen back, sorry, would be choice 2. Because you can't have a graph that intersects the x-axis in 4 places like it does with choice 1. See, so we've got 1, 2, 3, 4 places. And these two values here are real values, where these two values here are imaginary. Okay, so again, just kind of reiterating that choice 2 would be the correct choice. Right, so for number 15, what I did was I just kind of wrote choice 1. It said that we had to add f of x and g of x. So here's my f of x, and here's my g of x. Okay? Choice 2 says, yeah, do the same thing, but subtract them. So just be careful. So here's my f of x minus, now my g of x is a binomial. So anything that comes after a minus sign, if it's more than one term, we put it in parentheses because in a second we're going to distribute that negative through. Okay, then choice 3 said multiply f of x and g of x, so I just wrote them as two separate things in each in its own set of parentheses. And here it says f of x divided by g of x. So I took the f of x and I divided it by g of x. Now notice I put a 0x here because remember when we do long division, if we're missing a value, we just write 0, in this case x is what we're missing. All right, so I would just kind of go through these and I would add like terms. So in choice 1, I would get x squared plus x plus 12. Now, the question says, which operation would not result in a polynomial expression? Well, this is a polynomial expression. It's a trinomial. So that then would not be the answer. So let's go to choice 2. All right, so I was saying that we should distribute that negative through, right? So that's going to give me x squared plus 9 minus x minus 3. So that's going to give me x squared minus x plus 6. Also a polynomial, right? Similar to number 2. I mean, different answer, but still a polynomial. Okay, in this case, a trinomial. So it's not choice 2. So then let's look at choice 3. So we're going to double distribute. So that's going to give me x cubed plus 3x squared. Then let me double distribute again, here and here. And that's going to give me 9x plus 12. All right, well, I don't have any like terms, but let's look at the fact that this is still a polynomial. Polynomial is anything containing 2 or more terms, and we've got 4 here, so we're good to go. All right, so, you know, I think we can safely assume that it is choice 4, but just to show you, if we start dividing, I'm going to get an x here, and then, just like on the last question, or 2 questions before when we did long division, x times x would be x squared, and then the x times 3 would be 3x. And remember that we want to circle and change the signs. So circle, change the sign, circle, change the sign. And let's keep going here. So that's going to give us a negative 3x. Let's bring down that 9. And then I know that I can multiply by a negative 3. Okay? So negative 3 times that x is negative 3x. And negative 3 times the positive 3 is negative 9. Alrighty, so we do one more set of circle change. So circle change the sign, circle change the sign. This is gone, and that is 18. So you see that we have a remainder here, right? So I'm just going to rewrite this. So then I have x minus 3, and I have a remainder of 18, and that is over x plus 3. This is not a polynomial expression because of that fractional piece at the end there, that remainder. Okay, so then the answer again is choice 4. All right, so notice that what they want us to do is a minus bc. So a is negative 3 plus 5i minus b, which is 4 minus 2i, multiplied by c, which is 1 plus 6i. All right, so I'm going to do some double distributing. So let me just bring down that negative 3 plus 5i, and then the minus sign, and let's double distribute here. So I'm going to get 4 plus 24i minus 2i, and then minus 12i squared. Now, notice that I kind of left something out here. You have a minus sign followed by a whole lot of junk. So, hopefully, you're saying to yourself, Ms. Carter, you forgot the parentheses. Okay, so, but before I actually start distributing that negative through, let me just simplify those parentheses, what's inside the parentheses, just a little bit. So 4, and then right here, those are like terms, so that's going to be plus 22i. And let's look at this. Remember, I squared is negative 1. So that is going to turn that into 4 plus 22i plus 12. Okay? Which is going to give me 16 plus 22i. Let me throw that in parentheses. And I'm going to bring this guy down now. Negative 3 plus 5i. Okay, so now is when I would like to distribute that negative through to everything. And I could have done it earlier, but I like to simplify things first. Doesn't matter though. So we're going to get negative 3 plus 5i minus 16 and then minus 22i. And let's add our like terms. So we have negative 19 and then we have what? Minus 17i. And there is our answer. And then if you go up and you look, that is choice 3. All right, so if you look at the question, it's asking for the margin of error. Now, sometimes when we have margin of error, we would always kind of look up in this corner, or sometimes they put it in this corner, and they'll give us the mean and the standard deviation. And so then we know margin of error, we know that that is 2 standard deviations, but we don't have that in this case. So remember that there's a formula for the margin of error, and that is equal to 2 times the square root of p times q over n. All right, so if you go through this and you read the question, it says that 55% of them said they would vote for the candidate. Well, there's your p. So that's 0.55. Now remember, if your p is 0.55, then your q is going to be 1 minus 0.55. Okay, which is 0.45. Then your n is always your population. And if you read the second sentence, it says his staff received responses from 900 likely voters. So there's your n. All right, so we're just going to plug everything in. So 2 times the square root of 0.55 times 0.45, and that whole thing is over 900. And then throw that in your calculator, and you're going to get 0.0, oops, that's supposed to be an equal sign, sorry, 0.03316. And if you go through and you look at that, we would see that that would be choice 2. All right, so for this question, I think there are different ways to do this question, obviously, but this is the way I went about it. So what I did was I looked at the scale here. So they gave me that that's a 1. So then I know, like, that's a 3. This number here is a 5. Here there's 7, and there's 9. You can choose any number you want. I chose the number 9. So I looked at basically those 3 dots. And then I kind of looked roughly at how high they were. So do you see that they're somewhere like under 30? So 5, 10, 15, 20, 25, it seems like they're counting by 5. So each of these slashes on the y-axis, so here's 5, right? So that would be 10, 15, 20, 25. So these guys are somewhere in that 20 to 28 range is what I'm guessing, okay? Pretty accurately guessing. So what I would suggest that you probably do is just take choice 1 and let's plug in 9 for our t value. So that's what I did. So I said, well, if t is equal to 9, then that would mean that w is going to equal 4 to the 9th power plus 5. Well, when I did that, I got a really large number. I got 262,149. Well, people, let's just look at this, okay? This value for W represents the Y value, see, right here, W? And this is certainly not 262,149. That's somewhere in the 20-ish range. So I know then that it can't be answer choice number 1. So then I would do the same thing with all of them. And let's just keep it the same number. So I'm plugging in this case, W equals 1.4. I'm going to raise that to the 9th power plus 2. And I worked that out. And I got 22.661. Well, that really does seem to make sense for what I have up here in the graph. Does it make sense that these values would be in the 20-ish range, right? Because this is 22.6. Yes, it does. So I'm going with that. Now, by the way, that is the answer, but just to show you, if I did the same thing here, I would just keep doing the same thing. So 5 times 2.1, and then raise that to the 9th power. And when you put that in your calculator, you get 3,971.4. Well, again, that doesn't make sense, okay? And then we would do the same thing with the last one here. So W equals 8 times 0.75 to the 9th power. And I ended up with 0.60068. Again, doesn't make sense. So choice 2 it is. All right, well, there's several ways that we can do this question. I'm looking at the equation that they gave me, and that I can't put that in my calculator because it doesn't have y equals. It says x equals. So what I actually did was I switched this around, and I was like, well, if I made that y equals, wouldn't that then be 3 to the x? Right? I switched the x's and the y's. Remember, that's called finding the inverse when you switch the x and the y values. Now, the reason why I did this is because I know that I can find out what the graph of this, I can find out what that looks like pretty easily because it's a y equals, and I can plug that into my calculator, right? So if you put that in your y1 and then do a zoom 6, you're going to get a picture, and that picture is going to look like that, right? Now, if you remember but remember how I got there, okay? So the way that I got there, though, was by taking the inverse of this equation. So I took this equation, I switched the x and the y's around, and that gives me the inverse. So this equation here is the y equals 3 to the x. Remember, when you want to find an inverse graph, basically, all you're doing is you're taking the graph that we have here and we're reflecting it in the line y equals x. Okay, so let me just pick a different color here. So then my graph is going to look like that. So here is your x equals 3 to the y. And then you can see that that's answer choice 2. Now, just so you know, this is also equivalent to y equals log base 3 of x. Because the inverse of an exponential, this being the exponential, is a log. Okay? So, I don't know if you remember, hopefully you do at this point, circle the base, run the race. See? The base is 3, the exponent is y, and that's what we have right up here. Okay? So again, answer choice 2. Okay, please make sure that you read this question carefully because it says which statement is not correct. So we're looking for the one that's false. Now, the first thing that I would take note is look at the original equation, and we notice that this number here is less than 1. So if something's less than 1, we have a depreciation or decay that's occurring. And so if you look at choice 1, it says the car lost approximately 19% of its value each month. And notice that this says after T months. So that does make sense, number 1, because choice 1 says each month, and the original question is saying after T months. The other thing also is it says that the car lost value, which would make sense based upon what we have here, right? We have a depreciation here. There's also a loss. And then the way that we would figure out that loss is doing 1 minus 0.81. So when you do 1 minus 0.81, right? 1 minus 0.81, you will get 0.19, which is 19%. So choice 1 does make sense. However, they want the one that is not correct. All right, so let's look at choice 2. It says the car maintained approximately 98% of its value each month. All right, now, so let's look at that for a second here. So we know that the initial cost of the car is $32,000, right? And then the formula says times 0.81. And then it says T over 12. Can't we take that T over 12? Do you remember that we can take that and say, well, that's really equivalent to 1/12 T? Remember that? Okay, because 1/12 times T is still T over 12. Now, the reason why I'm doing that is watch. Because then in the next step down, we can take that 1/12 and we can bring it on the inside and multiply it. Well, I should say raise 0.81 to the power of 1/12. Okay, so let me say that another way. Remember that when we have 1/12 times T, let's back up. Look down here. Remember when we have a power raised to another power, we multiply these two exponents. And that will give us this 1/12 T that we have up here. So all I did was I split up these two products and brought one inside and left the other one outside. Okay? All right, now what I'm going to do is I'm just going to take this and I'm going to put that in my calculator and work that out. So let's bring down the 32,000, and then in your calculator you're going to do 0.81 to the 1/12 power. And when you do that, that's 0.9825. And then we just bring down the T. So let's look at this number here. It's less than 1, so we know that we're losing value. I'm sorry. Well, there is the initial question, sorry, was a depreciation of the value of the car. And so then we know that this value right here is going to be how much the car maintains of its value each month. So it's maintaining 98.25%, which makes sense, which is choice 2, but again, the question's asking which one is not correct. So it would not be choice 2. All right, which leads me to, and I already said it, I don't know if you caught it, but look at choice 3. It says the value of the car when it was purchased was $32,000. Well, that's the original cost of the car, which is right here. And that is true. And again, the question's asking for which one is not true. So we know the answer is choice 4 by process of elimination, but let's go through it anyway. Okay, so let's go back to the original equation, which was V equals 32,000 times 0.81 to the T over 12 power, correct? All right, so let's look at number 20. I'm actually going to go backwards. I will tell you that the answer is going to be choice 1, but I'd like to kind of explain why, and I think it'll be a little bit easier if I go backwards. So if we look at the equation, all right, the original equation is 32,000 times 0.81 to the T over 12 power. All right, so a couple of things. Remember that when we have an exponential equation like this, this is always your starting amount. So the value of the car when it was purchased in this case was $32,000. So we can eliminate choice 3 as being the answer because this one is asking for which statement is not correct. And we know that the original price then of the car would be $32,000. So we eliminate choice 3. All right, next thing also is T is represented in months. So if we look at this, this is T over 12. Okay, so this is however many months out of a total of 12 months in a year. So this fraction represents a year. And then we would just put in however many months, for example, we're given. So this is what I mean. So look at choice 4. So choice 4 says the value of the car, here we go, 1 year after it was purchased. So how many months are in 1 year? 12, right? And remember, T represents months. So again, I'm going to say it again. Choice 4 says 1 year after it was purchased. So then what I'm going to do is I'm going to find out the value of that car 1 year after it was purchased. Well, 1 year means 12 months, right? Out of 12, which is really just to the first power. So then you can take your calculator and do 32,000 times 0.81. And when you do that, you're going to get $25,920, which is choice 4. But again, the question's asking for which statement is not correct. So it's not choice 3 and it's not choice 4. All right, let's go to choice 2 then. Choice 2 is saying the car maintained approximately 98% of its value each month. Now, we know obviously, hopefully we know obviously, that this is a depreciation because this value here is less than 1. Okay? All right, so, but we have to do a little bit of fancy footwork here on choice 2. So remember again, we start with 32,000 times 0.81. Now, do you see how that says T over 12? Do you guys remember when we started these kinds of questions? We could break that up and say 1/12 T. It means the same thing. And the reason why we do that is, I hope you remember, that we have that power to a power rule. So hold on and let me write this and then I'll explain it to you. I'm moving the 1/12 inside the parentheses, staying as an exponent, and then to the T power, I'm leaving the T on the outside. All right, so this is why I'm doing that. Because remember, if I have an exponent raised to another exponent, right, power to a power, remember we can multiply these two. So when I multiply 1/12 times T, don't I get 1/12 T? So this way here is just another way of writing 1/12 T, like what I have up here. But the reason why we do that is because I can find the value of 0.81 to the 1/12 power in my calculator, and that may help us figure out the value that the car is maintaining each month. So let's bring down this 32,000, and then I'm just going to take my calculator and do 0.81 to the 1/12 power. And when I do that, I get 0.9825. And bingo, look at that. This is the percentage that represents what the car is maintaining in value each month, which matches with choice 2. So therefore, it cannot be the answer because we are looking for something that is not correct. So then lastly, obviously, by process of elimination, we know the answer is choice 1. Let's talk about that for a little bit. Now, first of all, it's saying that the car is losing 19%. All right, well, let's go with this. We knew that this was a decay because this number here, right, is less than 1. And if we do 1 minus 0.81, don't we get 0.19? So then you ask, well, how come that? I don't understand. Well, here's the issue. The issue is, remember that this exponent really, together with the T over 12, represents years. So for example, if I put a 12 in here, that's 1 year. If I put a 24 in here, that's 2 years. If I were to put a 36 in here, that's 3 years. This question is not saying each year, it's saying each month, and that's what's incorrect. Tricky, right? So the answer is choice 1. All right, so we have a fractional equation, so I would start by looking for a common denominator. Just remember that this is a monomial x, and this x is part of this binomial, so they're not the same thing. So I am going to multiply this first fraction by x plus 3, both top and bottom. Now, the second fraction already has the x plus 3, but it needs the x to match that first fraction, which then means the numerator is also going to get multiplied by x. And the same thing with the third fraction. That also already has the x plus 3, so it too only needs the x. All right, because there's an equation, we can then cross off our denominators, and then we're going to simplify those numerators a little bit. So I'm just going to start by distributing that 2 in the first fraction through to both terms there. So I'm going to get 2x plus 6 minus, then I'm going to distribute this through, which will give me 3x squared equals x squared. Okay? All right. Then from there, I'm looking at this and I'm saying, that's a quadratic because I have x squared terms. So I would think to take everything, move it to one side, and set it equal to 0. And I like to keep the x squared positive, so I'm going to add 3x squared and add 3x squared. And then while I'm at it, I'm going to subtract 2x and subtract 2x and subtract 6 and subtract 6. So everything here will disappear, and I'll be left with 4x squared minus 2x minus 6, and that will be equal to 0. All right, now I do see that I have a common factor that I can divide out, and that would be 2. So that's going to give me 0 equals 2x squared minus x minus 3. All right, now my lead coefficient there is something other than 1, so I know I have to rainbow. So what multiplies to negative 6 and would add to a negative 1, right? That's what that's asking. So remember, we bring down the first term and we bring down the last term. And then we ask ourselves again, what multiplies to negative 6 and adds to negative 1? So that would be a negative 3x and a positive 2x. Then we're going to group, and we're going to take out a common factor. So in the first grouping, that common factor is going to be an x, and we're left with 2x minus 3, right? And then in the second grouping, there isn't anything, so let's just take out a 1, and that will stay 2x minus 3. And almost last but not least, the factors that we took out get grouped together in one set of parentheses, and our doubles go in another. All right, I'm out of room here, so I'm going to bring it up over here. So I have x plus 1, that factor, and I have 2x minus 3. And I want to set this equal to 0, right? Now, if you read the question, it says, what is the solution set? So when we are looking for solutions, remember we want to find out what x is actually equal to. So we're going to take each of these factors and we're going to set them equal to 0. So on the left side here, I'm going to subtract 1 and subtract 1. And I'll get x equals negative 1. So there's one solution. And then over here, I'm going to add 3 to both sides. That'll give me 2x equals 3. And then I'm going to divide by 2. And I will get x equals 3/2. So there's another solution. Now, the last thing that you just want to make sure that you do is check both of these solutions so that you want to make sure that they do not make any of the denominators of the original equation equal to 0, because that would make the fraction undefined. So if I put in a negative 1 here, do you see that this can't possibly be equal to 0 if I put a negative 1 there? The only value that could make this x a 0 is if x were 0. If you go over here, the only value that would make this fraction undefined, is if x was negative 3. And the same thing here, if x was negative 3. And neither of these answers are 0 or negative 3. So both of these solutions we're going to keep. We're not going to reject any of those. So then we just go up, we look at our answer choices, and we see that it's choice 4. Okay? All right, so for number 22, just go back and look at number 20. It's the same question. It's a repeat, so you just got a freebie. All right, I always draw pictures. I think that works best. So I'm going to plot the focus, which is negative 2, 5, 1, 2, 3, 4, 5, which would be right there. So there's the focus. And then the directrix is y equals 9, which would be a horizontal line at y equals 9. So right there, I know that my parabola opens downward, because remember that the parabola can't cross over your directrix. And the vertex of your parabola should be halfway in between. So if this is at 5 and this is at 9, then we're going to say right there, that would be your vertex. And I'll tell you what that is in just one second. So your parabola is going to look like that. All right, now, so the coordinates of your vertex would be negative 2, comma, 7. All right, so I know it opens downward. So the formula is y equals negative 1 over 4p. Now remember why it's negative, because the parabola is opening down. Okay, and if the parabola is opening up or down, it's always a y equals x minus h, that quantity squared, plus k. All right, now remember, h is the x value of the vertex, and k is the y value of the vertex. All right, so here we go. Oh, and let's talk a minute about p. So now remember, p is, let me pick a different color. P will be the distance from the directrix to the vertex, or from the vertex to the focus. They should both be the same, right? Because the vertex should be smack dab in the middle. So your P is 2. All right, so then we have y equals negative 1 over 4 times 2, right? 4 times 2. And then we have x minus my h value. Now that's the x value of the vertex, which is negative 2. Now I know that looks ugly, we'll fix it in a second. Plus k, which is the y value of your vertex. Oops, which is a 7. Sorry about that. I'll rewrite it to make it look a little bit prettier. So here we go. Y equals negative 1 over 8. Now remember, minus a negative is the same thing as saying plus 2 squared plus 7. And that's the equation of your parabola. Now, if I look at what's up there, I don't really see that. I kind of sort of see it. So if I look at this, I'm like, I notice a couple of things. So a couple of things that I notice is that the y is not by itself here, nor is it by itself here. So that must mean maybe I could take this 7 and bring it over to the other side of the equal sign, right? So I'm going to try that. So I'm going to subtract 7 and subtract 7. And again, just in an attempt to make it look more like the answer choices. If it was an open-ended question, I'd be done already. So I have y minus 7 equals negative 1/8 times x plus 2, that quantity squared. Right, now I'm starting to have it look a little bit more like what I've got up there. See, I've got y minus 7. Well, these guys have y minus 7s, but wait a minute. Something's a little fishy here. Look, they have squareds. We don't have squareds over here. Look at what's squared. The x plus 2 is what's squared. So then I think we can safely assume, I think you guys would all agree, that it can't be choice 1 or choice 2. Okay, so Then let's look at the difference between choice 1 and choice 2. One of these guys has a negative 8, and this guy here has a positive 8. So could we probably say it's choice 4 because we've got a negative down here? Really not understanding it? Of course we could, but we're going to understand it. All right, and P.S., the answer is choice 4. So the deal is this, though. We don't want that negative 1/8 in front of that x plus 2 quantity squared. So remember, the way that we can get rid of it is by multiplying it by its reciprocal, which is negative 8 over 1. Because what that will do is that will cross out that fraction. But what I do to one side, I have to do to the other. And then I'm just going to squeeze it over here. I've got negative 8 times y minus 7 equals, now remember the fraction disappears now, and we have x plus 2, that quantity squared. And that is why it's choice 4. Okay, so for number 24, I type that equation into my y1, exactly as you see it. Make sure you use the alpha y equals when you get to that pi over 45, and make sure that you're in radian mode. So then the next thing that I did was I didn't know how to quite see a picture. So I started by finding my x min and my x max. Why can't I ever make x's look pretty? Okay, so I made my x min 0, and I made my x max 150. Okay, then for my y's, I made my y min 0, and I made my y max 350. And the reason why I did that was, this is talking about, I want to know where its highest point is, right? Well, remember, we find the highest point in any graph by taking its vertical shift plus the amplitude. So if you add those two together, you'll get 310. So I tend to err on the side of caution, go up a little bit higher than 310, so I went up to 350. All right, so then I just hit graph after that. So when you hit graph, you're going to get a picture, and it's going to look something like that. Okay, so what it's asking is how many seconds? Now that's time. And if you look at time in the equation, that's like your x value. This is your y value. Your height is your y value, and time is your x value, or on your x-axis. So it wants to know how many seconds it takes to go from the bottom of the wheel to the top of the wheel. So basically, what's this time right here? Because I'm starting here at time 0, and then tick, 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 here I get up to the top. How much time has passed? That's what that's asking for. So all I did was I did second calc max. So if I do second calc max, that's going to give me that maximum value. And again, remember though that I'm looking for the x value because that represents time. So the x value, which represents time, when I do second calc max, is 45.6337. Okay, and then when you go over to your 4 choices, the only one that makes any sense would be choice 2. All right, so they gave you the point 2, -1. So that means to the right 2 and down 1. So there's your point in the 4th quadrant. So we went, let's try a different color here. Sorry about that. We went to the right 2, and then we went down 1. Okay, now remember, we can make a bow tie triangle in the 4th quadrant. That's a little right angle symbol there. And we know the length of this side is 2, and the length of this side is 1. Yes, we went down 1, but the length of that side is still 1. So if you look here, we're still unsure about what that hypotenuse is, right? So remember, we can do Pythagorean theorem. 2 squared plus 1 squared equals c squared. So that's 4 plus 1 equals c squared. So 5 is equal to c squared, which means that c is the square root of 5. All right, so that would be our C value right there. Now, let's read what it's asking for. It says find the exact value of sine. All right, so remember, if we do SOHCAHTOA, sine is the opposite over the hypotenuse. So our opposite, and remember, they're talking about an angle theta that's in standard position. So we start on the positive x-axis and we would work our way around. And then the reference angle to that angle that I just drew would be this angle right here inside that triangle. So when I refer to opposite over hypotenuse, I'm referring to the side that is opposite that reference angle. So that would be 1 over the hypotenuse, which is radical 5. Now we don't want to put this into the calculator and get a decimal value because it's asking for an exact value. And an exact value means leave it as a fraction, or in this case we want to leave the radical in there. Now, but the problem is we can't have a radical in the denominator. We have to rationalize it. So remember, the way that we do that is multiply the denominator by itself. But what you do to the denominator, obviously you need to do to the numerator as well. All right, so I'm just going to write this down here because I can't fit it. So sine theta equals radical 5 over, and now just remember, radical 5 times radical 5 is just 5. Or you can think of it as radical 5 times radical 5 is radical 25, but the square root of 25 is still 5. All right, now there's one thing I left off, and you can do it in the beginning, you can do it at the end. Obviously, I'm doing it at the end. Remember, all students take calculus. So we are in the 4th quadrant, but we have sine. So that means our radical 5 over 5 should be a negative. So there's our answer. This is asking you to express the answer in a plus bi form. So immediately I go to quadratic formula. So my a is 2, my b is 5, and my c is 8. So I have x equals negative b, which is negative 5, plus or minus b squared, which is 5 squared, right? And 5 squared I know is 25, minus 4 times my a, which is 2, times my c, which is 8. And the whole thing is over 2 times a, which is 2. All right, so x equals negative 5 plus or minus the square root of 25 minus 64, right? That whole thing is over 4. Now let's just talk about this. So the square root of 25 minus 64, if I do 25 minus 64, I'm going to get negative 39. Now remember, we can't have a negative underneath the square root, but we should remember that that means we have an imaginary unit. So that's like negative 1 times times regular 39. Now 39, there's no perfect square in 39. I would attempt to break it down if I could, but I can't. But do remember that the square root of negative 1 is an I. So that's really I times the square root of 39. So let's go back over here. So I have negative 5 plus or minus I times the square root of 39, and that whole thing is over 4. All right, now the question does say to express the answers in a plus bi form, so we do want to separate this. So remember that that 4 is really the denominator for the negative 5, but it's also the denominator for that I radical 39. Okay, so I'm going to split this up sort of and write negative 5/4 plus or minus, and then I radical 39 all over 4. And there's your answer. Now some people like to, and it's totally fine, if you don't prefer to have that I here and you want to have it at the end, that's okay. Do me a favor though, please make sure that that I is not looking like it's underneath the radical with the 39 though. You want it clearly on the outside there, okay? Now we have to be very careful with this question because it says that we have to use that Pythagorean identity. Otherwise, we could do this different ways, but it gave us that identity, so we're going to have to stick to it. All right, well, I do know that the cosine is negative 0.7, so I'm going to replace cosine with negative 0.7, but notice that that cosine value is squared, and then I'm going to set that equal to 1. All right, so let's work that out. So I got sine squared theta plus, that's going to be positive 0.49 when I square negative 0.7, and that equals 1. So then I'm going to bring over that 0.49, and then I'm going to get sine squared theta equals 0.51. All right, so I'm going to try to get sine theta by itself. So remember, the opposite of squaring would be to take the square root. Now remember, when I take a square root, I technically need a plus or minus. So I've got the sine of theta equals plus or minus the square root of 0.51. Now let's talk about this for a second. Because if you read the question, it does say, using the identity, find the value of tangent to the nearest hundredth. Here's our cosine value, and here we go. And theta is in quadrant 2. Now we're in the second quadrant. So we have sine in the second quadrant. So I think we just did a question like this, right? Sine in the second quadrant, all students take calculus. Sine in the second quadrant is positive. So if I'm going down here and I'm looking at my plus or minus, I can drop the minus because I know I'm in the second quadrant and that sine value is going to be positive. Okay, so let me just write this one more time. So sine theta equals just the square root of 0.51. Now, if I put that in my calculator, I'm going to get 0.71414 and blah, 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 blah. And it keeps going, okay? All right, now, we didn't answer the question because the question is asking for tangent. So, here we go. Well, I know that tangent is the sine of theta over the cosine of theta, right? So I just found the sine value. It's 0.71414, blah, blah, blah. That's all in your calculator still, right? And the cosine value they gave me, they said it was negative 0.7. So all I have to do is divide that, and I guess I shouldn't be lazy here. Let me write down that tan theta. So when I divide that in my calculator, I'm going to get negative 1.02, because it says to the nearest hundredth, by the way. All right, now, just make sure, again, let's go back. They're telling us that we're in the second quadrant. Second quadrant sine is positive, but we're looking for tangent. So we should have a negative value here, which we do. So then, we can safely assume that we're good to go here. There's our answer. Okay, 28. This is a very strange question, but they want to basically know, explain one statistical bias, just one, not 5 million of them. So in other words, why would this really not be the best idea? And there's a million different answers here, but let's face facts. How many of us have driven down the road, or maybe you're too young to, really be paying attention yet, but I've driven down the road and I've seen this before. I don't have the desire to call. I'm busy trying to get from point A to point B, on top of the fact that they tell us that, we shouldn't talk on the phone while we're driving a car. So that would be another reason why. So it could be anything from, well, we shouldn't really be talking on the phone while we're driving, so not a lot of people will call this number. So how can we rate a driver based upon the number of positive comments when maybe people who are out there driving are trying to be cautious and not dial while driving? The other thing is, again, maybe people are just lazy and they don't want to take the time to call. Or maybe if it's a certain truck, maybe there's several different drivers throughout the day that drive that truck. So then if somebody does call that number, you may not know which driver they're referring to. So there's so many different reasons why there would be a statistical bias. But again, I'm just going to kind of verbalize it because to write it is just annoying. But one statistical bias, again, is people are being cautious when they drive. And they're not going to call while they're driving because it's dangerous. And they're certainly not going to memorize the phone number and then pull over to the side of the road and call the number. Or some people are just lazy and don't want to take the time to call. Those are just two possible options. I'm sure you can come up with a few more. All right, you have seen this question before, I know you have, but let's go through it anyway. So Elizabeth waited for 6 minutes at her favorite fast food restaurant. So 6 minutes. And she was very upset about this. She notified the manager. She was like, this is ridiculous. And the manager assured her that this was a very unusual occurrence. So a study was brought about with regards to this restaurant, and they found out that, here we go, the mean wait time was 226 seconds. Now let's just stop for a second here, because the mean wait time was 226 seconds, but she waited 6 minutes. We have two different time units here. So you're going to have to convert one to the other. Guys, it doesn't matter which one you choose. Okay, so you can convert minutes to seconds or you can convert seconds to minutes. Who cares? So I'm going with converting 6 minutes to seconds. So I have 6 minutes, and I know there's 60 seconds in every minute. So that would be 360 seconds. That way we're just comparing like units of time. All right, now the other thing says, the other bit of information they give you here is that the standard deviation was 38 seconds. Another reason why I changed 6 minutes to seconds, because that way everything's on the same unit of time. Now, it says, given these data and using a, here we go, 95% level of confidence, was Elizabeth's wait time unusual? Well, I know that 95% level of confidence is the mean plus or minus 2 standard deviations. Well, they gave us the mean. They said it was 226, and they gave us the standard deviation, which was 38. So I'm going to do 226 plus or minus 2 times 38, which is 76, right? All right, so let's make an interval. So in the interval on the left, I'm going to do 226 minus 76. And in the right side here, I'm going to do 226 plus 76. So I end up with 150 here, and that would be seconds. And on the right-hand side here, when I add 226 plus 76, I get 302 seconds. Okay, so this interval right here is the 95% confidence interval. All right, now let's look at what we have here. So Elizabeth waited for 6 minutes, which was 360 seconds. Now look at this interval. Do you see that 360 seconds is not in there? So 360 seconds is outside that 95% confidence interval. So let me write that. So 360 seconds is outside the 95% confidence interval. So if that's the case, is that an unusual occurrence or does that happen a lot? Okay, think about that. If it's outside that 95% confidence interval, that would be what we would call unusual. So the manager was right. An unusual occurrence. And Elizabeth is just going to have to sit tight now, isn't she? Okay, so we need to express this in simplest radical form. So let's start with 2x to the 3/2 power, right? Then, in the denominator, notice that the entire piece here is being raised, the 16x to the 4th is being raised to the 1/4. But there are two things in here. There's the 16 and there's the x to the 4th. So what I'm going to do is I'm going to split that up. So we're really doing 16 to the 1/4 power multiplied by x to the 4th, I should say, and then that to the 1/4 power as well. That makes sense? I just split that up. All right, so now let's keep the numerator because there's not a whole lot I can do with that at this moment. And I'm going to do 16 to the 1/4 in my calculator, and that ends up giving me 2. And then x to the 4th to the 1/4, remember, power to a power, you multiply exponents. Well, 4 times 1/4 is just x, right? So I'm going to be left with 2x in the denominator. Well, I look at this fraction and I say, oh, well, we've got common terms here. We can cross those out now, can't we? And then I'm going to look at what I have left here, and I see that when I have division, and let's look, right, this fraction line means division. Really, I have the same base, and when I have division, I can take my exponents and I can subtract them, right? Well, this exponent in the denominator is technically a 1. I mean, we don't have to write it, but I'm going to. So then really what I'm doing then is keeping the base, and then I'm going to subtract the exponents. So 3/2 minus 1, which is really x to the 3/2 minus 2/2, right? I'm going to continue in this direction. And when I subtract those two fractions, I get x to the 1/2 power. Now, if it said to express this whole fraction as a fractional exponent, I could leave it, and that is my answer, but it says simplest radical form. So you should remember that a 1/2 power is the same as a square root. And there we go, simplest radical form. Alrighty, so they want to know the x value of which function's x-intercept is larger. So remember, an x-intercept is where the y value is equal to 0. So if we look at the chart, which represents h of x, we can see that the y value is 0 when x is equal to 2, right? So the x-intercept here is 2, 0. All right, so now I need to look at f of x. Well, I can plug that into my y1, can't I? And I can get a picture of what that looks like. And when I do that, that's what I'm going to get. With this x-intercept being 5, 0. So it says the x value of which function's x-intercept is larger, f of x or h of x. So then we would say that f of x has the larger x value, right? Of its y-intercept. I'm sorry, that's so messy. Because 5 is greater than 2. All right, so we have a fractional equation again. So we need to find a common denominator. And I notice that I have a binomial x plus 3. So that means these 3 fractions here are going to need an x plus 3. But I also notice I have a factor of 2, 6, and 2. So if I'm looking for a GCF, I would say, oh, let's go with 6 because I can multiply these 2's by 3's, right? So here we go. Let's do this in a different color, actually. All right, so I'm going to take this first fraction, and it needs a 6. So let's multiply the numerator and the denominator by 6. Now, this second fraction also needs to be a 6, but it's already got a 2, so I really only need a 3 there, right? But it's also missing that binomial x plus 3. So let me plop that in there as well. All right, the third fraction, well, it already has the 6, so then that just needs the binomial x plus 3. And lastly, this 2, well, that needs the 3, right, so that we get 6 in the denominator there, but we also need that binomial of x plus 3. Now remember, when you have an equation that involves fractions, once you get the common denominator and you've adjusted the numerators, you can cancel out your denominators. All right, so I have 6 times a negative 3 plus 3 times x plus 3 equals x times x plus 3 minus 3 times x plus 3. That's what's left in the numerators. Okay, so I've got negative 18. I'm going to distribute this 3 through. That's going to give me 3x plus 9 equals, let me distribute that x through, and that's going to give me x squared plus 3x. And let me distribute this negative 3 through. Don't forget that minus sign there. So that's going to be minus 3x minus 9. And let's try to combine some like terms here. So on the left-hand side, I'm going to get negative 9 plus 3x. And on the right-hand side of the equal sign, I'm going to get x squared. Oh, look at that. Those 3x's are going to cancel out. Minus 9. So I have a quadratic here, and they want me to solve. So remember, what we try to do then is get everything to the side where the x squared is by adding like terms and changing signs and whatnot, and let's set it equal to 0. And then we'll just go from there. So I'm going to bring over this 3x by subtracting it, and I don't have a like term on the right side, so I'm just going to throw it out there. And then I have a negative 9, so I'm going to make that plus 9 and plus 9 here. So my left side disappears, and I have 0 equals x squared. My 9's disappear, minus 3x. And there I go. All right, well, I notice that there's a GCF of an x. So let me take that x out, and I'm left with x minus 3. Okay, now if we go back and we read the question wants you to solve. So remember, that's like your t-chart, and you take each of these factors, and we're going to set them equal to 0. Well, here's one of them. Done. X equals 0. And then this one over here on the right would be x equals 3. Now remember what I said in one of the previous questions. You have to be careful. You want to take your solutions, and you want to check these two solutions to make sure that they don't make the denominator of any of the fractions equal to 0. We don't want to have a fraction be undefined. So if I put in x equals 0 here, notice I don't get 0 in the entire denominator. I get 0 plus 3, which is 3. So that's good. And I have no places here where I would plug in x equals 0. So that way I know that x equals 0 here. That solution will work. Now let's try 3 here. If I put in a 3 here, will I get 0 in the denominator? No, I will not. So then we can say that these two answers are our solutions. Now, you don't have to write them in the curly brackets, or you can. That's totally up to you, but both of those answers work. Okay? All right, so I assume that you've already taken the time to read this question. It's a half-life question. So remember, we are going to make an equation, and to the right of the equation will be whatever the original amount was. And initially, that patient was injected with 20 milligrams of this substance. And then, after a certain amount of time, there will be approximately 7 milligrams left. So that will be our final amount. Okay, so then remember that what goes inside the parentheses is 1/2, and then it's time It's to the power of time over half-life. If you read the question, they're asking you to determine the amount of time. So we don't have the time, but we do have the half-life, and that's supposed to be a t. And here we go. Let me do that in a different color so you can see it. Okay, so the half-life is 8.02 days. So that is what's going in right here, because it's time over half-life. All right, so let's look at what we have here and let's see what we can do. So we're trying to basically find that t, but it's an exponent. So you know we're going to have to log somewhere along the way. But let's try to simplify a little bit first. Please be careful. You can never ever multiply 20 times 1/2 because this 1/2 is connected to this exponent. So our next best bet then, since that would be a very bad bet, would be to get rid of that 20 by dividing. All right, so that's going to leave me with 0.35 equals, I'm going to make that 1/2 0.5, I hope you're okay with that, to the t over 8.02 power. All right, so here we go. I need to bring that exponent down. And the only way that I'm going to get that exponent down is if I log both of my bases. So I'm going to put a log in front of the 0.35, and I'm going to squeeze in a log right there. But remember, what that's going to do is going to make that exponent plop down in front. All right, now that's pretty nasty looking, so let's make that look a little bit prettier. So I've got the log of 0.35 equals t over 8.02, and that's going to be multiplied by the log of 0.5. All right, so let's try to get that t by itself. So I'm going to divide by the log of 0.5, both sides. Okay, and then from there, I've got the log of 0.35 over the log of 0.5, that whole thing. Now you can put that in your calculator. It's 1.51457, blah, 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 blah. And that value would be over 1, and this is equal to t over 8.02. So I'm just going to cross multiply. Okay, so I'm going to take these guys right here and multiply them, and then obviously 1 times t is just t. So we have t equals, so again, let me just kind of say that again. You could take this value, plug that into your calculator, and you'll get 1.51457. Stop the video if you want to do that, that's fine. So really what you're doing then is you're taking that 1.51457 and you're going to multiply it by the 8.02. And that will give you 12.14 days. Now, this says to the nearest day, so that would be 12 days. All right, so if you read this question, you will see that it asks you, or discusses, about how long it's going to take an investment to double at a certain interest rate, and it's compounded continuously. So remember that compounded continuously is A equals P e to the RT power, right? Okay, now P would be our initial amount, and our A would be an amount after a specific period of time. In this case, they don't give us an initial amount if you read it, so but we do know that the ratio between the initial amount here and the final amount here is a 2-to-1 ratio because it's asking how long it's going to take for the investment to double. So really what you could do is for P, you could really pick any value. Let's say I pick 10, and then A, you just need to make sure that it's double that, which would be 20. So again, for P, you could really pick anything. Let's look at the R. Okay, so the R is the rate, which is 3 3/4%. So that's 3.75%. But remember, we want to write this as a decimal, so we're going to take this decimal and we're going to go back 1, 2 places, So our r is going to be 0.0375. Okay? All right, so let's plug everything and see what we get. So, again, for A, I'm going to put 20. And for P, I'm going to put 10. You can put something else, but just make sure that your A is double whatever your P is. Okay, so then we have E to the R, which is 0.0375. And then we have T, because it's asking for how long is it going to take, and that represents time. All right, so let's start by dividing both sides, by 10. I'll cross that out, and we'll get 2 equals e to the 0.0375 t power. All right, so remember that we now have an exponent that has a variable in it, and we need to get this exponent down. But because we have an e, remember we won't log, we'll do the natural log. So we're going to ln both sides. So I'm going to ln this base, I'm going to ln this base, and remember the exponent comes down in front. So we have the ln of 2 equals 0.0375t, and that's going to get multiplied by the ln of e. Now remember, the ln of e is just 1, so we can just cross that out because it's just 0.0375t times 1. All right, so then we are going to divide out the 0.0375 so that we get the t by itself. And then the rest is calculator work. So the ln of 2, and divide that by 0.0375, and that will give us 18.4839. And it says to the nearest tenth of a year, so then t would equal 18.5 years. And there's your answer. Okay, so we have to solve algebraically for all values of x. So when I look at this, I say to myself, well, I do have a radical equation here, so I know that I'm going to have to get the radical by itself. But I think before I do that, let me just start by, rewriting that left-hand side for now, because I see something on the right-hand side I want to address first. So 6 minus 2x, then plus x equals, and I'm going to distribute this 2 through first. So that's going to give me 2x plus 30, and then minus 9. And I'll take care of that 30 minus 9 in a second. So now I'm going to try to get the radical by itself, so I'm going to move the x over. So that would give me the square root of 6 minus 2x equals, and then I'll have x plus 21. Okay. All right, so now I want to get the radical. The radical is by itself, I should say. Now I want to get rid of it. So remember, I would do that by squaring both sides. And don't forget that this means to write that term twice, and we're going to have to do some double distributing there. Okay, so on the left-hand side, I'm going to have 6 minus 2x because the radical and the square will cancel each other out. And then over here, I'm going to be doing some double distribution with x plus 21. All right, so then I get 6 minus 2x equals x squared plus 21x plus another 21x, and then plus 441. Okay. Now I see that I have a quadratic, so I know I'm going to be scooting everything to the side with the x squared and setting it equal to 0. So I'm going to add this 2x over. I'm just going to stick it right in the middle here because I know that these three guys are like terms. I'll deal with that in a minute. Minus 6 and minus 6 here. All right, so I get 0 equals x squared. Now when I combine all those x terms, I have 44x, and then I have plus 435. Now, listen, off the top of my head, I have no idea what numbers add to 44 and multiply to 435. So remember the trick that you can do in your calculator. Go to your Y1 and put in 435, divide by X, then go to your table of values and look for two numbers that would multiply to 435. All of them will. But you want to figure out which two would add to 44. Okay? So when I do that, I end up with 29 and 15. Oops. There we go. Now this does say to solve, so let's do our t-chart. And then I'm going to get x equals negative 29 and x equals negative 15. Now you have to be very careful with these because remember when we have radical equations, you definitely want to check these to make sure that your solutions will actually work in the original equation that you were given. Okay, so I'm going to kind of section off here, and I'm going to start with negative 29. So if I do 6 minus 2 times negative 29, okay, and then minus 29, oh boy, I'm going to run out of room here, 2 times negative 29 plus 15, definitely going to run out of room here. I'm so sorry, I'm going to stick a minus 9 up there, okay? All right, so when I work this out, underneath the radical there, I'm going to get the square root of 64. Then I have minus 29. And then on the right side, I'm going to get 2 times negative 14 minus 9. All right, well, I know that the square root of 64 is 8, right? And 8 minus 29 is going to give me negative 21. And then over here on the right side, 2 times negative 14 is negative 28. And negative 28 minus 9 is negative 37. So that does not work. So we're going to reject negative 29. And then you're going to do the same thing again with the negative 15. So again, 6. Then we have minus 2 times negative 15 minus 15 equals 2 times negative 15 plus 15 minus 9. All right, so underneath this square root on the left-hand side, I'm going to get the square root of 36 minus 15 equals, now over here on the right-hand side, I really have 2 times 0, which I know is just 0. So I really have negative 9 on the right here. And on the left, I've got 6 minus 15. And 6 minus 15 is negative 9. So that one does work. So then my only solution would be negative 15. Okay, so I assume you've already read the question. It says to calculate the difference in the, oops, why do I always do that? It says to calculate the difference in the means. So here are your means. And it says scented minus unscented. So we're going to do 23 minus 18, and I'm going to get 5. So there's the difference in the means. Okay, now, if you read the question below that, it says a simulation was conducted in which the subject's scores were re-randomized into two groups 1,000 times, and the differences of the group means were calculated each time, and the results are shown below. All right, so then if you look below our simulation results, you'll see that they're asking two questions. So they want you to use the simulation results to determine an interval. Okay, so an interval representing the middle 95%. Well, here we have the mean and we have the standard deviation. So all we're going to do is we're going to do the mean plus or minus 2 standard deviations. So we're going to do 0.03 plus or minus 2 times 1.548. Okay, so that's going to be 0.03 plus or minus 3.096. And then we're going to subtract 3.096 from the 0.03, and then we're going to add it. All right, so we end up with negative 3.066 through, and then our maximum there would be 3.126. And it says to the nearest hundredth. So I'm just going to, where am I going to put this? I'll put it right up here. So to the nearest hundredth, that would be negative 3.07 through 3.13. So there's your interval that represents the middle 95% of the difference in means. Okay, now let's read the next question. It says, is the difference in the means in Joseph's experiment statistically significant based on the simulation? Well, remember that up on the first part there, the difference in the means was 5, right? So if we look down here, here's 5, and you see that that would include 3 dots. That's 3 dots out of a sample of 1,000. Which is 0.003. And as a percent, that's 0.3%. That's a very, very small number, or a very small percent. So we could then say that the difference in his means, which was 5, right? 5 or more, because look, see, or more, right? 5 or more, or you could say 5 or higher. And look how often that occurs. It occurs right here, less than even 1% of the time, okay? But we usually use, remember, our go-to statement is that it occurs less than 5% of the time. And so remember, when something occurs less than 5% of the time, that's very rare. So we would say then, therefore, remember that means therefore, statistically significant. Statistically significant. So if you get a percent, and let me just kind of point to this, if you end up with a percent that's higher than 5%, that's more likely to occur, and that would not be statistically significant. But because our percent here is so small, the chances of being all the way up here is not very large. So that number 5 or higher is going to occur less than 5% of the time. So that definitely makes that statistically significant. That's like a standout figure, so to speak. All right, so you should read through this question a couple of times so that you get the general idea of what it is that they're asking. They're giving you 2 scenarios. So option A, I'm going to just color code and let's look at it in blue. So option A is having his parents start with $5,000. Oops, let's keep that color-coded blue, for his 16th birthday, right? And then they are going to, let's see, pay him 4.5% interest compounded annually. So that would be 1 plus the rate, which is 0.045. Now, compounded annually means 1 time a year. So technically, what I do have here is I have 0.05, and technically this would be over 1 because it's compounded 1 time a year, but we don't really have to write that. Okay, that'll make more sense, I think, when we get to option B. And then that's going to be raised to the n power because it says that n is measured in, here we go, years. Okay, now if we look at option B, I'm going to color code that in red, same $5,000 on his 16th birthday, right? He's getting an interest rate of 4.6%, but this is compounded quarterly, which means 4 times a year. So what you're going to do is, unlike option A, where that 0.05 is technically over 1, this is 0.046, and this is going to be over 4 because it's being, the interest is being compounded quarterly, 4 times a year. And then, remember the formula also would state then that we raise this entire parentheses to the 4, because quarterly, n power. So there are your two equations. All right, then in the second part, it's saying that Seth plans to use the money after he graduates from college in 6 years, and determine how much more option B will give him earning than option A will earn him. So I'm basically going to find A of 6. So I'm going to do this in my calculator. So 5,000 times, well, I know 1 plus 0.045 is 1.045, right? And I'm going to raise that to the 6th power. So when I do that, I end up with $6,511 and 30 cents. Now, we have to compare this to option B and see how much more we would get in option B. So when I do this, I'm just going to do 5,000 times 1 plus 0.046, that's over 4, and then to the 4 times 6 power, or to the 24th power, if you will. Okay, so when we do that, option B is going to give me $6,578. Again, we just put this in our calculator, and 87 cents. Okay, so let's just squeeze this in here. Now they want to know how much more option B will give us than option A. So then what we're going to do is we're going to take these two values and we're going to subtract them. So $6,578.87 minus $6,511.30. So we have a difference of $67.57. Okay, and lastly, the last part of this question asks how long it's going to take for option B to double Seth's initial investment. So, remember his initial investment was $5,000. If we want to double that, then obviously we're going to end up with $10,000. And then we have 1 plus. Now option B, remember, was 0.046 over 4 to the 4n power, right? And it's asking, determine to the nearest tenth of a year how long it's going to take. And that's time, which is your n, which stands for years. Okay? All right, so let's try to get that n by itself. So I'm going to do a couple of things here. The first thing I'm going to do is I'm going to divide by 5,000. So that will give me 2 on the left. And then I'm also going to simplify what's in that parentheses there. That gives me 1.0115, and that's to the 4n power. Okay, so, well, hopefully you realize at this stage of the game that I have an exponent that I need to bring down in front. So that's going to require me to log both of these bases. I'm just going to squeeze that in there. And then my exponent is going to drop down in front of that. Okay? All right, so let's make that look a little prettier. So then really what I have is I have the log of 2 equals 4n times the log of 1.0115. Let's divide out that log of 1.0115. and then that's going to give me, now I would ask you to keep this in your calculator, but when you divide the log of 2 divided by the log of 1.0115, it's 60.619580, blah, blah, blah. And that will be equal to 4n. So keep that long decimal in there, and then all we have to do is just divide that by 4. And that will give us n equals 15.1548. Now, that would be years. It says determine to the nearest tenth of a year how long it would take for option B to double his initial investment. If we mathematically round this, we will end up, what do we have to go to the nearest tenth? We will end up with 15.2 years. There's your answer.